In this video, we're going to take a look at transformations of graphs. Now, what I've got here is a graph which shows a sketch of y equals f of x. Okay, now for y equals f of x, we have a minimum point at -2, -1. Okay, and we can see that again on our diagram. And what I want to do here is write down the coordinates or evaluate the coordinates of the minimum point for the following equation. So y equals f of x plus 1. Now, in this case, because the effect is outside the bracket here, so we're adding or subtracting a number here outside the bracket. So for example, here with part B, you can see it's inside the bracket. That means it affects the x coordinate only. When it's outside the bracket, that means it affects the y coordinate only. So this tells us that we need to add 1. So because it's plus 1 here, that means we add 1 to the y coordinate. Because there's nothing in the bracket here with the x, that means we just leave it as it is. So the x coordinate stays the same. In this case, that would be -2. And the y coordinate here will be -1 plus 1, giving me 0. Okay. So essentially what's happening here is everything's moving up 1 unit. So our minimum point here would then be here. Okay. So that's the solution to part A. So that's the coordinates of the minimum point. For the next one here, like we said, this is now inside the bracket. So this means it affects the x coordinate only. But we have to be slightly careful here. Now this is x minus 2, so the misconception here is that we subtract 2 from the x coordinate. And this is incorrect. We don't subtract 2, we actually do the opposite. We add 2, okay? So we add 2 to the x coordinate. If that was x plus 4, we'd subtract 4. If it was x minus 3, we'd add 3, okay? So the coordinates of the minimum point for this equation will be -2 plus 2 for the x coordinate, which is 0. And the y coordinate stays the same. There's nothing affecting the y coordinate outside the brackets, so that stays as it is. That's -1. Okay, and that's the solution to part B. And for the last one here, y equals f of minus x. In this case, now with it being inside the bracket, it affects the x coordinate only. Now we have to be slightly careful here. With this being minus x, well, what this is telling us is we're not adding or subtracting anything to the x coordinate. What we're actually doing is we're multiplying the x coordinates by -1. So we don't write that number there, but in front of this x, there is a -1. Okay, so we'll take the x coordinate and times it by -1. So -2 times -1, -2 times -1, that would give me +2. So just be careful there. Okay, so that would be +2. And we're not doing anything to the y coordinate, so that stays as it is. So that's -1. Okay. And there we have it. So that's the solution to part A, part B, and part C. Now let's take a look at an example here where we don't have a sketch of the curve. Not that we necessarily need it. I guess it just helps as a visual guide. But what we've got here now is the maximum point of the curve with the equation at y equals f of x. And this has coordinates 4, 3. And what we want to do is write down the coordinates of the maximum point with the following equations. So what do we do here? Well, if we start with part A first, what I've got is 2 parts to consider. We've got this +2 here on the outside, and I've got this x minus 1 inside the bracket. So if we start with the +2 first, remember, just like we saw with this example here, that tells us what we need to add to the y coordinate. So we need to add 2 here. So the y coordinate will become 5. So if it's 4, 3 to start with, add 2 to the y coordinates, that will be 5. So 5 for the y coordinate. And this x minus 1 here, that tells us what we need to add or subtract to the x coordinate. So because this is x minus 1, that means we need to add 1 to the x coordinate. So 4 plus 1, giving me 5 there. So we get 5, 5 for the first part. For the second part here, so y is equal to 2fx, or 2 lots of f of x. In this case, with this being 2 here on the outside, so it's not in the bracket, so it doesn't affect the x coordinate. What it does is it affects the y coordinate only. Now in this case, because it's not on the outside here at the end, like we saw with part A, this means we need to times now by this number. So we times the y coordinate by 2. So the x coordinate will stay the same, so that will be 4. And the y coordinate we times by 2. So if that's 3, 3 times 2, giving me 6. So we get 4, 6 there for part B. And for part C here, again, there's 2 parts to consider. We've got this part here on the outside, so that affects the y coordinate. It's not inside with the x. We've also got this 2 here inside affecting the x coordinate. So let's consider the -3 first. That's a little bit easier. So we should be getting quite good at this by now. Remember, this tells us we need to subtract 3 from the y coordinate. So that will be 3 minus 3, giving me 0 there for the y coordinate. For the x coordinate here now, What we do is we either times by 1 over this value here, so 1 over 2, so we times by 1 over 2, or we divide by this value. I like to just divide by this value. It's the same thing. So if I've got 4 here, 4 divided by 2 simply gives me 2 there, okay? So we get 2 there for the x coordinate. So for part C, we get 2, 0 as our solution. So we've worked through a couple of examples there together. Now it's your turn. So what I'd say here is pause the video, have a quick go at this part here, and we'll take a look in a moment at what you should have got. So hopefully you got an okay with this practice question here. Let's take a look now at what you should have got. So what I've got here is a sketch of the curve y equals x squared minus 2x plus 1. And we've got this minimum point here at 1, 0. And what I want to do here for part A is just write down the coordinates of the minimum point of this equation. So we've only got this minus 4 on the outside here, so that tells us that it's only affecting the y coordinate. So if my y coordinate here is 0, this tells us that we need to subtract 4 from the y coordinate. So in that case, we're going to get 1. So the x coordinate doesn't change. So 1 there, and 0 minus 4, giving us minus 4. Okay, so we get 1 minus 4 for part A. For part B then, so what we've got here is f of x plus 3. So we've been inside the bracket here. That means it affects the x coordinate only. So what we do here is we do the opposite of this. So because we're adding 3, that means we subtract 3 from the x coordinate. So 1 minus 3 gives me minus 2. Okay, that's the x coordinate there. And the y coordinate doesn't change. We don't have anything affecting the y coordinates. That will just still be 0 there. And for part C here, we've got y equals f of a half x. So y equals f of a half x. Okay, like so. Now here, remember, this is inside the bracket, so it affects the x coordinate only. And remember, we divide by this number in front of the x. Okay, so we take our x coordinate, 1, and we divide by this number. So what's 1 divided by a half? Well, dividing by a half is the same as timesing by 2. Okay, so this is the same as 1 times 2, which would give me 2 there. Okay, so we get 2 there for our x coordinate. Remember, there's nothing affecting the y coordinate, so that stays as it is. Okay, and that's what you should have got for part C. And to finish with here, just 2 more examples to have a go at. So pause the video now, have a quick go, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with these 2 parts here. Let's take a look now at what you should have got. So what we've got here is the minimum point of the curve with the equation y equals f of x. And the minimum point has these coordinates, so minus 3 and 2. And what I want to do here is write down the coordinates of the, I should say, minimum point. So the minimum point with the following equation. So I've got y equals f of x plus 1 minus 4. So again, there's 2 parts here that we need to consider. We've got the minus 4 on the outside here, so that tells us that we need to subtract 4 from our y coordinate. So our y coordinate here will be 2 minus 4, giving me minus 2. So that's the y coordinate. For the x coordinate here, well, we look at the inside of the bracket. So this is x plus 1. And remember, we do the opposite to this. So this is x plus 1. We subtract 1. So minus 3 minus 1 gives me minus 4 there. Okay, so we get minus 4 minus 2. So that's for part A. For part B then, we don't have anything inside the bracket, so the x coordinate stays as it is. That will be minus 3. But we do have this negative, or this minus sign here in front of the f. So what does this do? Well, remember, we times by whatever this number is in front of the f. So don't get confused here. We have this negative symbol, but this is actually minus 1 f of x, like so. Okay, so that tells us that we times the y coordinate here by minus 1. So if we've got 2 times minus 1 is equal to minus 2. In that case, we get minus 3 minus 2 there. Okay, and that's our solution. So that brings us to the end of this video on transformations of graphs.